Have you ever stopped to think, what would happen if the sun had a nervous breakdown and sent an explosion directly to Earth? Would we be prepared for the impact? This intriguing question leads us to a fascinating and vital topic for all of us. The sun, this bright star that provides us with light and warmth, is also a dynamic celestial body full of surprises. Scientists assert that the sun follows cycles of approximately 11 years. These cycles influence our climate, can trigger solar storms, and also impact the technology we use daily. Have you ever imagined your internet connection being cut off or your car's GPS failing because of a solar storm? In today's video, you will discover how the sun goes into attack mode, how this impacts Earth, and what scientists are doing to protect our everyday technology. Get ready to understand a phenomenon that not only shapes our planet, but can also shape our future. What is the solar cycle, and why does it matter? To understand the impact of the sun on our planet, we first need to define the solar cycle. This cycle is a variation of activity that occurs approximately every 11 years. During this period, the sun goes through peak phases, known as solar maximums, and calm periods, known as solar minimums. During solar maximums, solar activity, such as sunspots and eruptions, is intensified, while during solar minimums, this activity decreases significantly. This dynamics is crucial as it directly affects Earth and its conditions. The primary effects of these cycles are felt in the upper atmosphere and in Earth's magnetic field. During solar maximums, the sun's intense activity can cause solar storms that, in turn, interfere with communication systems, such as radio and satellites, and can cause failures in electrical grids. Moreover, the levels of radiation we receive from the sun also increase, which can have implications for human health, especially for those exposed at high altitudes, such as airplane pilots. But what really causes these solar cycles? The phenomenon is explained by the concept of solar dynamo. This theory involves the interaction of plasma flows and magnetic fields inside the sun. As the plasma moves and changes, it generates magnetic fields that, in turn, influence solar activity. This complex system of interactions leads to variations in our star, and consequently to the changes we feel on Earth. Thus, understanding the solar cycle is essential not only for science, but for the protection of our technology and the health of the planet. The solar storms and their devastating consequences. Solar storms are impressive and potentially devastating phenomena, characterized by massive explosions of energy that occur on the sun. These explosions can unleash enormous amounts of radiation and charged particles into space, directly affecting Earth and its space environment. These events can be incredibly powerful, and when directed towards our planet, have the potential to cause serious problems. There are three main types of solar storms, each with its own characteristics and distinct impacts. The first are coronal mass ejections, CMEs, which involve the release of billions of tons of solar plasma and magnetic fields. When these ejections reach Earth, they can trigger geomagnetic storms, causing blackouts in electrical grids and interfering with GPS systems. The second type is solar flares, which are sudden and intense bursts of radiation. These explosions release radiation in various forms, such as X-rays and ultraviolet rays, which can affect satellites and even pose a health risk to astronauts outside the protection of Earth's atmosphere. The third type is radiation storms, which occur when energetic particles are launched towards Earth. These storms can increase radiation levels at high altitudes, posing a danger to pilots and passengers on transcontinental flights. One of the most famous examples of a solar storm is the Carrington Event, which occurred in 1859. This intense solar storm caused extreme damage to the technology of the time, such as telegraphs catching fire and communication systems failing. Auroras were also visible at much lower latitudes than normal, an incredible spectacle, but signaling the impact of the storm. With the solar cycle currently growing towards its next maximum, events like the Carrington one may repeat. However, this time the consequences could be much more severe due to our interconnected digital infrastructure. Electrical grids, communication systems, and even personal devices could be severely affected, leading to a critical alert about the need for protection and preparation for these solar storms. The effect of solar storms on space weather. Space weather refers to the dynamic conditions occurring in the interplanetary space, primarily affected by the solar wind and the charged particles that the sun launches into space. This combination of solar phenomena creates an environment that is constantly changing, impacting not only Earth but also operations throughout the solar system. One of the main concerns related to space weather is how the charged particles generated during solar storms can interfere with communication systems. When these particles hit Earth, they can cause significant disruptions in radio and GPS communications, resulting in signals that fail or deviate. This can have far-reaching effects, especially in sectors that rely on real-time communication, such as aviation, maritime navigation, and military operations. The safety of flights and travel can be compromised, increasing the risk of accidents and misunderstandings. In addition to communication disruptions, space weather also has a crucial impact on space exploration. Solar storms pose a significant threat to astronauts and their missions. During a solar storm, radiation levels increase, exposing astronauts to risks that can affect their long-term health, such as an increased likelihood of cancer. In interplanetary missions, where astronauts are far from the protection of Earth's atmosphere, exposure to solar radiation can be even more intense, requiring mission teams to take additional precautions. These challenges emphasize the importance of monitoring space weather and developing strategies to protect terrestrial infrastructure and space missions from future solar storms. Space agencies and private companies operating in space are increasingly aware of the need for technology to predict and mitigate the adverse effects of space weather, ensuring the safety of astronauts and the continuity of communications and operations on Earth. The role of scientists in monitoring the sun. Scientists use a variety of tools and technologies to observe the sun and monitor its activity. Among the major innovations are solar telescopes, such as the Daniel K. Inouye Solar Telescope, located in Hawaii. This telescope is designed to capture detailed images of the solar surface and its dynamic features, allowing researchers to study phenomena such as sunspots and flares. In addition, the Parker Solar Probe, launched by NASA, is on a historic mission to approach the sun, collecting data on its magnetic field and solar particles. This information is essential for better understanding solar behavior and how it can impact Earth. Advancements in computational models and algorithms have also revolutionized the prediction of solar events. Scientists can now simulate solar activity with greater accuracy, allowing for the prediction of solar explosions and storms in advance. This predictive capability is crucial as it provides valuable information for space agencies and companies that rely on satellite-based technology. By anticipating when a solar storm may occur, teams can prepare to mitigate the effects. There are practical measures in place to protect Earth. In the event of an imminent solar storm alert, it is common to perform temporary shutdowns of satellites and reorganize flight routes to avoid higher-risk areas. These precautions help protect critical infrastructure and ensure that the impact of extreme solar events is minimized, safeguarding both technology and the safety of people on land and in space. Are we prepared for a super solar event? As the solar cycle progresses toward a solar maximum, the possibility of a catastrophic solar event becomes more relevant. Events such as coronal mass ejections, CMEs, have the potential to wreak havoc on our infrastructure, affecting electrical grids, communication systems, and even the health of satellites in orbit. The growing solar activity in the coming years could mean that we are more vulnerable than ever, especially considering our dependence on advanced technology. Thus, it is essential that we analyze what could happen if a large-scale solar event occurs and whether we are truly ready to deal with the consequences. Existing contingency plans vary from country to country, but many are still in their early stages. The development of emergency protocols to deal with a supersolar event is crucial. Measures such as the disconnection of electrical grids during an extreme solar event and the creation of temporary shelters for sensitive equipment can help mitigate damage. Additionally, investing in resilient infrastructure and upgrading early warning systems are important steps that governments and companies can take. As our world becomes increasingly interconnected, the question remains, are we ready for a large-scale solar storm? This question should lead us to think critically about our preparation. In the upcoming videos, we will explore more about these issues and other threats the universe may hold for us. Stay tuned and keep informed, because knowledge is the key to resilience. Through a better understanding of these phenomena, we can recognize the importance of preparing for the possible challenges that may arise. Did you enjoy this content? Then subscribe to the channel and turn on the bell to stay updated on the secrets of the cosmos. Just as the sun is unpredictable, you don't want to miss the next video that will reveal more mysteries and curiosities of the universe.